So now it's time to deal with numbers that have fractions as indices. Let's have a look at an example. So here we have 4 to the power of half multiplied by 4 to the power of half. Remembering your rule for multiplication, you just add these indices, so we get 4 to the power of 1, which we don't put to the power of 1, we just write 4. Now thinking about this, that is the same as saying the square root of 4 multiplied by the square root of 4. Well, square root of 4 is 2, times the square root of 4 is 2, 2 times 2 is just 4. So a to the power of a half is just the square root of a. The same occurs here with 4 to the power of a third. Again, multiplication, base numbers are the same. If we just add the index numbers, we end up with 4 to the power of 1, which is just 4. That is the same as saying the cube root of 4 multiplied by the cube root of 4 multiplied by the cube root of 4, which is just 4. So a to the power of a third is just the cube root of a. So hopefully you can see from above, if we follow that through, a to the power of 1 over n is equal to the nth root of a. So that again is now one of our rules. Okay, if we look at these examples above in more detail, we need to recognise that this 1 and this 1 is actually here. So we're raising a to the power of 1 underneath the square root and a to the power of 1 underneath the cube root. So we can take this one step further, and now we have a to the power of m over n, which is equal to the nth root, a raised to the power of m. So there's our other rule for fractional indices. One thing to point out here is how this m and n work, so I'll show that with an example. If we have 4 to the power of 3/4, that is the same as saying 4 to the power of 3 multiplied by 1/4, which is the same as saying 4 cubed all raised to the power of a quarter. And now we can rewrite that as the fourth root of 4 cubed, which is the same as saying the fourth root of 64. Okay, let's do a few more examples to sort of practice these. Okay, let's look at simplifying these. So the first one, we need to recognise that that is the cube root of 64, and the cube root of 64 is just 4. In this case, we need to notice the negative first of all. So what we've got here is 1 over 125 raised to the power of a third, and again a third is the cube root, so we've got 1 over the cube root of 125, and that is just 5, so we've now got 1 over 5. Now we should recognise the negative here, but we've got a fraction. So if you recall from earlier, we said if we have the negative here and we've got a fraction, we can flip the fraction and turn that into a positive. And we should recognise that to the power of a half is the square root. So we're looking at the square root of 64 and the square root of 49. Well, the square root of 64 is 8 and the square root of 49 is 7. In this case, we will rewrite this in a different way. That's the fourth root, which is raising all of this to the power of a quarter. And now we've got 16 to the power of a quarter and then 8a, all raised to the power of a quarter. 8 times 1 is 8, divided by 4 is 2. So we're left with a squared. So now I'm going to rewrite this back into the format of the fourth root. And the fourth root of 16 is 2. So we're left with 2a squared. So we need to recognise that this one is 25 to the power of a half times a 5. Well, the power of a half is the square root. So we know that is equal to 25 to the power of a half, all raised to the 5, which is the same as saying the square root of 25, all raised to the power of 5, which is the same as saying 5 to the power of 5. And 5 times 5 times 5 times 5 times 5 is 3,125. Last question, recognise the negative, which means if we've got a fraction here, we can flip the fraction and just replace the negative with a positive. Again, this third here is the same as saying 1/3 multiplied by 2. So actually 1/3 is a cube root. So we've got the cube root of 8 and the cube root of 125 all raised to the power of 2. Cube root of 8 is 2. Cube root of 125 is 5. That now is 2 squared, which is 4, and then 5 squared, which is 25. And that's dealing with fractional indices. There's one more video, and that's going to show you how to find an index number that is unknown.